Welcome to the first official developer blog for Train3D. I've posted a few videos in the past, and they've shown off what I've been working on, but I thought I'd make this a little more formalized. I'm going to show you some of the recent changes that I've made, explain a little bit about why things have taken so long since my last update, and also give a few hints on some of the developer tools I've been using, and also show off a few things I learned along the way. The biggest change since the last update is that I had to rework the entire track system. Originally, tracks were only allowed to be on tiles, so that was the flat tiles or the slope tiles. But as I worked along, I decided I really needed to support bridges and tunnels, and when I started thinking about bridges and tunnels, I realized very quickly that I actually needed to support full three-dimensional tracks. A lot of the code that I had already written was designed for the 2D environment. This included the pathfinding algorithm. I used a variation of the A-star pathfinding algorithm, but I needed to modify that to support 3 dimensions. Building tracks in 3 dimensions also posed a problem. The original track builder I had was based on the concept of connecting one corner of a tile to another corner of a tile, and that won't work when you're in the middle of the air. The first thing I had to do was change the path selection tool of where you were going to start, and so I built a column-based tool that had a transparent graph on the side of it so you could see at what height level you were at as you were building. I also modified the tool to be able to detect hits on existing track pieces so that you could click on an existing piece, whether it was in the ground or in the air, and start building from that location. Connecting tracks in 3D is also a little more complicated. There's more than just the mouse dragging from one corner to another on a tile. So I decided I needed a UI window. I built a tool window that has buttons for each of the available moves, and I built some code in to check to see if a move was valid or not and disable certain buttons when a move is no longer able to be added to the current track. I also decided to add buttons to let you switch between the track builder and the bulldozer tool and the station create tool in the same window. Instead of separate tools, they're all built into one now. I also added an option to have the camera follow turn on so that as you're building track, instead of having to manually move over to another screen, it will move along with the track builder. Building below the ground also presented some new challenges. I could have just turned the tiles off, but then you'd completely lose the context of where the landscape was in comparison to your tracks under the ground. So I added a new X-ray mode where you can turn the tiles into transparent grids and still get some context about where you are in the world. The transition points from underground to above the ground needed tunnels. At first I built a tunnel for my straight track and my slope track, but I soon realized that with the varied landscape, I was actually going to need tunnels for each individual track component. This posed an interesting challenge. How do you build a tunnel that can connect to the track pieces, but yet still sticks out of a land tile? So I knew my tunnels needed to be longer than a single unit. If the walls of my tunnel extended past a single unit, when two track pieces joined together, the walls would overlap and the engine would have a hard time rendering them because they'd be at the exact same location. To overcome this, I angled the ends of the tunnels in so that those surfaces were hidden and the parts that were 1 unit long exactly matched up to each other. This allows the tunnels to tile together seamlessly. I modeled the tunnels in Blender, and when I brought a few of them into Unity, I had some issues. Some of them had faces where the normals were pointed in the wrong direction. Blender has a nice mode that you can enable that shows your faces that are pointed towards the camera in blue and the faces that are pointing away from the camera in red. This made it very easy to spot the few faces that were incorrect and then easily select them and correct them by typing Alt-N and F to flip the normals. Some other tunnel models that I brought in were created by using a Boolean modifier on several smaller models and connecting them together. Along the way, a few vertexes weren't exactly lined up. This led to a warning message in Unity about overlapping or intersecting faces. Again, there's an option in Unity to turn on the mesh analysis mode and look for intersecting faces. They're highlighted in red, and this can help you find where the problem is. In some cases, it's easy enough to fix the problem by deleting the face and recreating, But if you've got a few stubborn things, you may discover that you have duplicate vertexes that are very close to each other. I solved this by using the mesh merge by distance and then adjusting the distance until I made sure that at least one vertex was cleaned up in my model. Then I recreated the faces using the new vertexes if I needed to. As I was modeling the tunnels, I learned about a few other Blender viewport options that make things easier to work with. I got rid of the built-in light and camera in my scene and instead turned on the shadow and cavity options, which still gives me some depth to the models as I'm working with them, but I don't have to worry about accidentally importing lights and cameras. Even though the art is still developer art and the art style isn't finalized yet, I was always a little frustrated that my land columns had the same texture on them no matter how far down you went. So for example, you grab a tile, raise it all the way to the top, you'll see snow from top to bottom. What I really wanted was snow to only show at a certain level. This was going to be a little bit tricky until I implemented my first shader. At first, my shader just had the 4 varieties of land as input textures, so instead of having to have 4 separate materials, I'd have 1 material and 1 shader, but 4 input textures, and it would swap those based on the height of the column. In the current version of the shader, I still use the 4 input textures for the top of the column, but I've created a single texture that represents all of the possible terrain from the sand up through the dirt and rocks and snow. And instead of having it mapped by the UV coordinates of the object, it's mapped to the UV coordinates of the world. This means that the texture stays in the same place relative to the height of the world, even when the column moves up and down. I also did a little demo to put some trees on the terrain. I decided to use a Perlin noise algorithm to distribute them around the landscape, just like I did for the terrain height, but using a different offset so I kind of get some randomness to where the trees are located. This was also my first example test of using level of depth. So the trees are actually different models depending on how far away they are. If you like the new Devlog format and you'd like to see more, please like and subscribe the video or leave your comments below. That does it for this Devlog. Until next time, thank you for watching.